You've probably heard of lasers. In science fiction movies, they look spectacular. But in real life, they're just as fascinating. Lasers are light sources of a single color that you can switch on and off very quickly. That makes them perfect for sending information. For example, through fiber optic cables. It's thanks to lasers that you can enjoy super fast internet at home. But that's only one application. When you zoom in on light, you get photons, tiny particles of light that we can create, send, and receive. The technology behind this is called photonics. In photonics, we don't use electricity, but light to process signals. This happens through tiny circuits on a photonic chip, similar to an electronic chip, but with light instead of current. Because the transmission of light isn't limited by electrical resistance, photonic chips can, at least in theory, be much faster and more power efficient than their electrical counterparts. Photonic chips are extremely sensitive to changes in temperature. If they get too hot or too cold, they stop working properly. That's why photonics is currently mainly used in controlled environments, such as data centers, where temperature can be kept stable. If we can make photonic chips stable over temperature, photonics can move beyond data transmission and be used for advanced applications, such as computing. And that future is already being built here at TU Eindhoven.
Hi, I'm Thomas, and I conduct research into making electronics, specifically for photonic integrated circuits. Over the last 60 years, there's been a major development towards making electronics smaller and smaller to what we now call chips, or integrated circuits in more technical terms. In the field of optics, a subfield of physics, there's been a similar development. In that field, people try to manipulate light with big, bulky components like lenses and filters that you can screw on a table. The size of such a circuit makes it hard to put into any product, for example, a phone or a car. It makes it harder to reproduce, and it makes it quite expensive to reproduce. Here in Eindhoven, we have thus been very interested in making these optical circuits on a chip, just like in electronics, so-called photonic integrated circuits. And these photonic integrated circuits are measured in this lab. The photonic chips are placed on a metal block, and everything around it is there to ensure that the environment of the chip is kept as stable as possible. And most importantly for me, the temperature of these chips is very well controlled. And that is done by placing a sensor just outside of the chip. And if the temperature is too warm or too cold, an active water pump under the table is used to control the temperature back to where you want it to be. My main research interest lies with the position of the sensor. It is just outside of the chip, so you get an approximation of how warm it is on that chip. And that's why here at TU Eindhoven I do my research specifically on making an electronic chip that can measure the temperature with the components inside of such a photonic chip.
Electronics may help make photonics more stable, and together they can achieve more than either could alone, giving each other the push out of the lab and into your daily life. TUE, where innovation starts.